So the next topic we will look at is still in thermal energy transfer. It is convection. Okay, so in the last lesson we looked at conduction. Today we're going to look at describing how energy transfer takes place by convection. And we're also going to explain the role of convection in everyday phenomena. So what is convection? So as conduction was the transfer of heat energy through solids, convection is the transfer of heat energy through fluids. And what do we mean by fluids? They are liquids, for example, water, and gases, for example, the atmosphere, by the upward movement of warmer, less dense regions of fluid. So just like conduction cannot happen in fluids, convection does not occur in solids. And just like conduction, a vacuum also does not allow convection. So what are convection currents? Okay, so here we have an image of a woman, okay, and she has cold air at the bottom near her feet, okay, cold air. So what happens is, as the cold air warms up, it begins to expand and become less dense. And as it becomes less dense, it begins to move up and occupy more space, as we see by the arrows going up. The hotter fluids are therefore less dense than colder fluids, and these hotter fluids begin to rise up, okay, to the top of the colder fluids. Now what happens as it gets to the top, though, is that the colder fluids begin to cool down, they become denser, the particles begin to combine, get closer together, and they begin to fall down again. This is known as a convection current, and is the path taken by rising hot fluids and sinking cold fluids. So you can see this example in convection. It's a demonstration we will do in class. So here we have a container containing water. It also contains at the bottom potassium permanganate crystals. And what we're going to do is slowly warm up those potassium permanganate crystals with a Bunsen burner. Okay, so it's going to be cold water with some potassium permanganate crystals at the bottom. So the potassium permanganate crystals are quite useful because they create a nice purple color which we can see moving. Okay, so when the bottom of the flask of water is heated by the Bunsen burner, what happens is that the cold water becomes warmer. And because of that, the molecules of water begin to get further apart, begin to become less dense, and begin to rise. And therefore, the potassium permanganate dye will also rise with the warm water. So you can see at the start, potassium permanganate is at the bottom of the container. As we heat it, it begins to move up the container. Okay, so when the water cools, it becomes denser at the top, and again, the water will begin to sink to the bottom again. So another example is the heating of a room by convection, just like our room. Okay, so here we have a hot radiator and we have cold air at the bottom. So as soon as the cold air hits the hot radiator, it's beginning to get more kinetic energy, it's beginning to rise, it's becoming less dense. Okay, so the less dense air is going to rise to the top of the room, and it's going to basically go up and start to cool down again. And as it cools down, it becomes denser and begins to fall again. So it begins again hitting the hot radiator, and it basically forms a convection cycle within the room. Okay, so that's an example from water, but we see it with potassium permanganate and cold water, and you can also observe it with another fluid, which is the air in the room, and that's also providing a convection current. Okay, so you see this with simple house water systems. Okay, so here's an example here. So the boiler heats the water. Okay, so at the bottom. Okay, the boiler heats the water, and as hot water boils, okay, it begins to rise because it is now less dense, and it hits the top of the storage tank here. The cold water at the bottom of the tank is more dense and falls back towards the boiler. And a hot water tap here basically takes the hot water from the top of the storage tank, and a cold water supply replenishes the bottom of the storage tank. You can also see it with engine water cooling systems. So we start off with an engine here. So the water is heated by the engine and it rises to the top here. Okay, The water is pumped through here to the top of the radiator, which is here. The fan here cools the water as it falls down, and the cooled water falls to the bottom of the radiator back into the engine so it can again cool the engine. And you can also see this in the atmosphere with thermals. So heated air provides lift for hot air balloons. So what happens is that you're using the flame here, okay, there's a flame here, to heat the air molecules. The air molecules expand and rise. You can also see this in the atmosphere with something called thermals. So heated land causes air currents to rise, and they're called thermals. And the thermals can be used by gliders to provide lift. You can also see this with birds. If you go up and look in the sky, they are going around in circles. Those are examples of birds using thermals to do exactly the same thing. That's what you see there. Okay, so you also see this with sea and land breezes. So during the day, the land is a lot warmer than the sea. Okay, and the sea breeze consists of cooler air moving from the sea to replace the hot air which is rising from the land. And during the night, the opposite happens. The land is cooler and the sea is warmer. So what happens is that the colder land air moves out to sea because it is warmer, and it's replacing the hot air which is rising above the sea. It's known as a land breeze. Okay, just to finish off, you can also see that in simple mine ventilation, what they used to do, they used to light a fire. Okay, so the fire causes hot air to rise up the shaft above it, and that means that colder fresh air can rush in to take place of the hot air that is rising up and escaping.